Let's start with a definition. A graph H is said to be a subgraph of a graph G if and only if every vertex in H is also a vertex in G. Every edge in H is also an edge in G. And every edge in H has the same endpoints as in G. So to be a subgraph of a graph, all of your vertices have to be in the original graph. It has to have the same edges as the original graph, and those edges have to have the same endpoints. So now that we know what a subgraph is, we can talk about what it means to be connected. So let's define that, and we'll look at a few examples. We'll say two vertices, V and W, of a graph G are connected if and only if there is a walk from V to W and we could say that the graph G is connected if and only if you take any two vertices, so given any two vertices, V and W in G, there is a walk from V to W. So let's look at a few examples and ask, are these graphs connected? So which of the following graphs are connected? So let's see, my first graph will look like this, and then that. And I'm not gonna label the edges here, I'll just label the vertices. So V1, V2, V3, V4, V5, and V6. If I take any two vertices here, I can find a walk from one to the other. So this graph is connected. Let's look at another graph. So again, I'm just going to not label any of the edges. So this graph is not connected because if I take any one of the vertices, so let's just say I take V1 and V4, there is no walk from V1 to V4, or from V2 to V4, or even V3 to V4. Let's look at one more. See, let's see my graph looks like V1 to V4. V2 to V3. So this graph is also not connected because vertex 1, if I look at either vertex 1 or vertex 4 and then either vertex 2 or vertex 3, there's no walk from V1 to V2. So what you can really do is you can kind of split this graph up into two pieces. So you can kind of think of it as being split up into V1 to V4 and V2 to V3. And each one of these pieces is connected. So these two individual parts, if I just look at them separately, each one is in itself connected. And so this kind of idea leads to something called a connected component. So let's define that. A graph H is a connected component of a graph G if and only if the following things have to happen. So first, H needs to be a subgraph of G. H has to be connected. And this third condition is essentially requiring that it's like the largest connected part of the graph. So no connected subgraph of G has H as a subgraph and contains vertices or edges that are not in H. All right, so we'll look at an example of connected components now. So example, let's find all connected components of the following graphs. So, well, we're just going to look at one graph. Of the following graph. So the graph will contain V1, V2, V3, E1, E2, and then this vertex V4. And then V5, V6, V7, V8, and then this will be edge 3 and edge 4. So you kind of just break off, separate, put edges that are together. So this would be one connected component. And here is a second connected component. And this final one, you're going to have to split it up into two pieces in order to get the connected components. So V5 to V6, this would be your third connected component. And then this other one, V7 to V8, this is edge 3 and this is edge 4. This would be your fourth connected component. So this graph would have 4 connected components in total.